Have you ever wondered how artificial intelligence is reshaping satellite operations in space? The enigma of AI in space is as vast as the cosmos itself. It's a complex world where algorithms and astronomical data coalesce, giving rise to fascinating concepts and applications. The role of AI in satellite operations is a topic that has been gaining momentum, both in academic circles and among space enthusiasts. This technology has been silently revolutionizing the way we interact with the universe, and it's time we delve deeper into its intricacies. From managing satellite constellations to making real-time decisions based on vast sets of data, AI is steadily becoming an indispensable tool. It's like a cosmic maestro, orchestrating a symphony of satellites that dance to its tune. In the upcoming scenes, we'll explore the evolution of AI in satellite operations, its current state, and what the future holds. The cosmos is calling, and AI is answering. Let's embark on this intriguing journey of understanding AI's role in satellite operations. Artificial intelligence has been gradually evolving and making its mark in satellite operations. In the early days, the advent of artificial intelligence in satellite technology was nothing short of a revolution. The initial stages saw AI being introduced to automate simple tasks, like adjusting satellite positions and maintaining optimal power levels. But even these rudimentary applications were not without their challenges. AI had to grapple with the complexities of space, unpredictable weather patterns, and the sheer magnitude of data that satellites generate. But as time progressed, so did the sophistication of AI. These challenges were not roadblocks but stepping stones, paving the way for more advanced applications. The industry began to see the potential of AI in enhancing the accuracy of weather forecasting, improving communication systems, and even detecting space debris. In the late 90s and early 2000s, AI took a significant leap forward. Machine learning algorithms and neural networks were integrated into satellite operations. This allowed satellites to learn from past data, predict future scenarios, and make decisions autonomously. This was a game changer. It meant that satellites could not only react to situations, but also anticipate them. Fast forward to the present day, and AI has become an indispensable tool in satellite operations. From aiding in the design and manufacturing of satellites to ensuring their optimal operation in space, AI is everywhere. It's helping us explore the uncharted territories of the universe, understand climate change better, and even keep our troops safe by providing real-time reconnaissance data. But perhaps the most remarkable aspect of this evolution is how AI has made satellite operations more efficient and cost-effective. Tasks that once required a team of experts and hours of manual labor can now be accomplished in minutes with a few lines of code. From being a novel concept to becoming an integral part of operations, AI has indeed revolutionized the way we operate satellites. And as we look towards the future, it's clear that the evolution of AI in satellite operations is far from over. This powerful tool will continue to shape and redefine the boundaries of space exploration and technology. The current state of AI in satellite operations is nothing short of a technological marvel, and the future holds even more promise. Today, artificial intelligence is revolutionizing how we operate satellites, making them smarter, more efficient, and more autonomous. It's an era where satellites can process data on board, make decisions in real time, and even self-correct when anomalies arise, thanks to the wonders of AI. The benefits are numerous. AI has reduced the need for constant human monitoring, saving both time and resources. It's also improved the accuracy and speed of data analysis. With AI, satellites can now sift through vast amounts of data, pinpointing only the relevant information and discarding the rest, a task that would be near impossible for humans to achieve in a timely manner. But it's not all smooth sailing. There are challenges to overcome. One of the most pressing is the need for more robust and reliable AI algorithms. These algorithms need to be able to withstand the harsh conditions of space and function without hiccups, even when communication with ground stations is lost. And then there's the question of ethics and regulations. As satellites become more autonomous, who's responsible if something goes wrong? These are complex issues that need to be addressed as we continue to innovate and push the boundaries of AI in satellite operations. Looking ahead, the future implications of AI in satellite operations are vast. We anticipate advancements in machine learning techniques that will further improve satellite autonomy. We also foresee the development of swarm intelligence, where satellites can work together in a coordinated manner, much like a hive of bees or a school of fish. In addition, AI could pave the way for more advanced Earth observation techniques, giving us unprecedented insights into our planet's health and helping us combat climate change more effectively. As we continue to explore and push the boundaries of AI in satellite operations, we can only imagine the technological advancements that await us in the future. It's an exciting time, filled with potential and promise as we journey further into the realm of AI and space exploration. As we continue to explore and push the boundaries of AI in satellite operations, we can only imagine the technological advancements